Diablo is like domestic violence. For many of us, it is a core childhood memory. Just like landmines, for example. While you was on summer vacation with your parents, I was fighting the Defiler with the Hellslayer and watched my parents get a divorce. Just signed the papers, the kid is fireball maxing. Today I'm gonna take a look at the Devolution X source code, which is a Diablo 1 port for modern systems. We're gonna take a look at the structure of the project and then go dive into the codebase, which at times will feel like we are deep in the dungeons. So let's start, devolutionx.com. The guys really put a lot of energy in this and it shows. It says, check out the wiki for what features are available and how best to take advantage of them. This is the only time in your life as a software engineer where you will take advantage of something. 100% of the time you are the one being taken advantage of. But let's go to the wiki. Home is empty, okay, code style. This is something we also saw in the Vice City source code. In case you have no hobbies, go watch my video about the Vice City source code. And by the way, anyone who wants to support the channel on a regular monthly basis, I made a Patreon, which is currently 0 Patreons. I'm not a fan of paywalls, so all my main content will always remain free and accessible to everyone. I don't want to exclude anyone who comes from a low GDP country like myself. And as a thank you, I'll include your name in my next videos, if it's not too embarrassing for you, of course. Okay, data types, booleans. Okay, they're using Clang format to format the code. That's pretty common. And what else? Comments, they're using Doxygen. That's also very common. Let's go to modding. So one of the main driving factors for the development for projects like this is the modding scene. People like modding cool games. And if you go on mods, as you can see, there are quite few mods. This one is like Diablo Autism Pro or something. Tell me you have no friends without telling me you have no friends. Okay, but now let's go back to the source code. Okay, as you can see, it follows the usual project structure. We have some build configuration stuff, we have third-party libraries, docs, source code, testing, and then also stuff like translations, assets, and so on. If we click on sources, we will see it is structured a bit differently than, for example, Doom 3 or the Vice City source code. So what do I mean by this? On top we have a lot of these subfolders, like in Doom 3 or Vice City, but the source folder itself contains a lot of source files. Okay? Now what is confusing for me, for example, is we have this items source file, but we also have like a folder called items, which contains validation source files. Okay. Now, I don't know what the reasoning behind this was, so I'm not here to judge, but would I personally do it this way? Probably not. Okay, let's close this for now, and let's open this. So, just like in my previous videos, I start with files that sound simple. This is a project with 1479 files with more than 500,000 lines of code, and since our time in this life is limited, I will only take a look at a small subset of the code base. To be more specific, we will take a look at the following sections: items, player, and levels, which in my opinion was the biggest, not shock, but let's call it surprise. So let's start with items. Okay, so first we can close the code window, and then we can search for the items.h file. We can now minimize this for a moment. And now everything that you see on the left side includes items.h, and everything on the right side is included by items.h. Okay, so you can also see it by the direction of the arrow. And this small arrow pointing at max items.h means that this macro is defined in items.h and it's being used by items.h. Okay. Now, if we want to understand how the items section work, we can ignore for a moment the left side and just focus on items and what's on the right side, okay? So now if you take a look at these includes, we will see that items includes also a item data.h file. So let's open it. And now we can minimize this again and we can open the code window. And it says, let's go back. Item data is an interface of all item data. And items.h is the interface of item functionality. So from an architectural point of view, this is very interesting that the developer separated items.h and item data. Every decision like this is at the end of the day a trade-off, okay? And anyone telling you differently is usually wrong. And when I say every decision, we are talking about technically correct decisions. I'm not talking about decisions like deciding to write a code that doesn't compile, okay? I'm talking about decisions that cover the requirement and are different in implementation. So every decision has its upsides and its downsides. Now your job as a good developer or architect is to pick the correct decisions for the specific use case. You can't determine the value of a fish based on how good it climbs mountains. So items.h contains the interface of item functionality, and items data contains interface of all item data. And now if you hide the code window, we can see that items data defines stuff like item indexes, item class, item equip type, and so on. So if you're not used to the color coding, the gray items with a flag are enums. These are functions. The grays without a flag are structs. These are global variables. And this is our namespace. Okay, now let's go back to items.h. And now if we expand this thing that we minimized before, we can see everything that's defined in items.h. So again, this is a namespace, these are macros, global variables, then we have enums for describing item quality, unique items, and so on. Then we have structs for player, item, global variables, functions, and global variables again. And as you can see, we don't have any classes in here, which I didn't expect at all. There's no single class in here, but we have structs, and structs and classes are not much different. The main difference is in the default access. So struct members are by default public and class members are by default private. Usually people use structs for plain data where you don't want to enforce encapsulation. I mean, you can do it, but that's some unwritten rule, okay? In this case, they decided to use structs instead of classes, and that's completely fine. There's nothing wrong with that. Now let's take a look at the source code. Okay, it starts with some macros, some const expressions, and then we have enumerations with item quality and unique items. Now, I would have expected to find this enumeration with unique items in items data, because from my point of view, this describes data and not generic item functionality, but let's keep going. Okay. I create info flag. Okay, this looks interesting. Let's stay here for a moment. So first, this turns off the Clang formatter for this code section. And what they did here is they created enums, which describe some properties of the item. And you can also read it in the comments in here. So CF probably stands for create info flag. And then you have like level for item level, or CF unique. Is the item unique or is it not unique? But if you take a look at the definitions in here, you will see that they do a bitwise left shift operation. So in case someone doesn't know what this means, so you have basically one in binary, and when you perform a shift operation, let's say bitwise left shift for 6, that means you get something like this: 1, 2, 3, 4, 5, 6, which in this case equals then 64. Okay, let's delete this. But why would anyone like to do this? So basically, these two lines kind of explain it. Let's take this as an example. So we have CF unique percentage 15 and we have CF unique percentage 1. Okay, CFU percentage 15 is shifted by 7. So that's basically 1, 2, 3, 1, 2, 3, 4. And then unique percentage 1 is shifted by 8. So it looks like this. And now you can use this OR operator to combine these two. So when you perform this operation, CF unique percentage 15 or CF unique percentage 1, you get as a result this. So CF useful is this. So if someone's still struggling to understand what's the purpose of this, it is much easier later in the code to check for just one condition, one definition, let's say CF is useful, than to check each of these conditions separately. And it is a lot of easier to maintain and read the code, especially if you have a lot of combinations, than to, let's say, write a bunch of AND or operations and so on. Okay, let's continue. So we have enums, then struct player, struct item, and this is where it gets interesting, randomly generated identifier. So I'm now guessing they initialize everything with some initial default values and then randomize the values for the items. Okay. Then we have some Doxygen comments. So this clears the item. Then we have is empty. Okay. Is equipment. This checks if something's a amulet, armor, helm, and so on. Then checking if something's a weapon. As you know, in Diablo, you have different weapon classes. Armor, okay, gold, blah, blah, blah. And then we have no discard. Okay. This is something that was introduced in C++17. Correct me if I'm wrong. What this does is basically generates a compiler warning if you discard or ignore the return value. So if I would later in the code write something like just is scroll, it would generate a compiler warning. Okay, now let's jump to the player code section. Again, we can just go home and then player.h. Minimize this. Okay, so I guess it follows the same principle as items. We have like items and items data, so I guess we will have player and player data somewhere. Here we go. So player implements the functionality and player data implements the data. But as we have seen in item, it is a very vague definition of what is data and what is not. If you expand now player again, you will again see namespace, macros, enums, functions, structs, and no classes again. So we see a consistency in first splitting player functionality or functionality and data, and then we also see a consistency in not using classes but structs. I mean, the whole code base seems to not follow the, I'm gonna call it classic object-oriented programming, where we have a base class and then derive other classes and everything is inherited in some way. And if you remember on my last video, there was a really long discussion around object-oriented programming. I mean, I said there are a lot of opinions on object-oriented programming, and the guys basically proved my point. They wrote paragraphs like someone's breaking up with someone in my comment section in real time. Okay, anyways, let's go to the player source code. So we can open this and then just click show definition in IDE. Interface of player functionality, leveling, actions, creation, loading, etc. Okay, let's go through the code. Namespace devolution again. Constant expressions, about inventory, belt items. Then we have walking directions, character attribute, strength. Okay. Now, if the player file defines the attributes, what does player data contains? Okay, let's take a look at player data. Interface of all player data. Enum class, hero class. So here they define the hero classes. And this is my problem now with this. We have player data which doesn't include player, and it defines like the hero classes. So in my opinion, it should be like player or character, and then character gets all these attributes of like being a warrior or mage, and then they all get their stats. In this case, it is mixed somehow, and I don't see a clear distinction. I don't see a clear line between player and player data. But you also need to understand that this code base originally wasn't written in C++20 probably. So that might be the reason. I don't know. And therefore, I don't want to judge if this is genius or not so genius. And I can just give you the advice whenever you review someone's code at work, before you start criticizing anything, just talk with the person. Ask them what their idea was, what is the reason you are using structs instead of classes, for example. And maybe there's a legit reason for something that you're overlooking, and that's completely fine. So now back to the code. A general comment when I scroll through all of this and this and this. As you can see, they have different ways of defining enums. So they're using, like, I'm gonna call it normal enums, then enum classes, then enums with underlying types, and just as I said, classic plain enums. So there's no strict consistency, and this is not a critique, that's just an observation. Okay, now let's go take a look to levels. This is the part of the code that surprised me the most, and you will see why. As many of you know, in the Diablo games, levels are generated randomly each time you start a new game. So the map layout will be different every playthrough. I know that when people want to implement such a behavior, they do it with Perl and noise. But I can't say surely that the original Diablo or this port are using the same type of algorithms. Now, what I would expect to someone who is not a game developer, and anyone who is, feel free to give me your opinion on this, I would expect to have some general kind of randomized creator engine, which is then fed with game data, which contains all the necessary level data like quests, monster types, and so on to build a level. So let's take a look at the source code. In the levels folder, we have this interface of general dungeon generation code, this gen_dunge file. And now if you go through the code, we will see it contains some general like macro definitions, enums again, like set level, skeleton, king, maze, poison water level. If any one of you played Diablo 1, you will remember this poison water level, since this was one of the many clues in a speedrunning scandal of Diablo 1, where some dude like manipulated his speedrun, and later on people found out that he was basically cheating, and this poisoned water in the well was a clear sign that he stitched up multiple runs into one run. Now we're gonna skip all of this. I'm looking for a specific struct in this file, and that's that's the mini set struct. So the mini set is used for manipulating tiles in this 2D grid system. It contains the dimensions, the size of the grid. Then it has this search pattern that's gonna be searched for, and this replace pattern, which is gonna be used to replace the pattern once the position has been found. Then it contains this matches function and place function. And we will talk about this mini set structs in a minute, but if we go back to the level source code, we will see that each level has its own level generation functions, okay? So this level has its own create L5 dungeon function, then the next level has its own create level 2 dungeon, L3 has create L3 dungeon. The only thing I'm not sure about why level 1 has like level 5, create level 5 dungeon. And now if you open the source code of the first level, we will see that the code starts with defining these mini sets. And to keep everything simple as possible, I'm gonna take the smallest mini set in here, so the mini set lamps, and let's try to sketch out how I assume the algorithm works. So we can open this sketch. So it seems like first the map grid is randomly generated. So you can imagine it like something like this. And let's make this thicker. The thicker the better, if you know what I mean. And now imagine this whole grid is populated with elements, and one element is like an integer. You're trying to make it to oversimplify it. So you would have something like, I don't know, like this. And now the whole grid is populated with elements like these. Okay, this is our generated grid pattern, our initial grid pattern. This is just a stupid example, okay? It doesn't work in reality like this. It doesn't look like this. But now we have a mini set, and a mini set in this case is, for example, this mini set lamps. It has a size of 2 by 2. This is the search pattern, and this is the replace pattern. So our algorithm for placing this mini set randomly on the map will go through this grid pattern element by element and look for this pattern 13, 0, 13, 13. Okay, let's imagine it is somewhere in here 13, 0, 13, 13. And now the mini struct, in this case we will make it purple. We'll have the elements 129, 0, 130, 128. Okay. 129, 0, 130, 128. Am I correct? Yeah. So this is the pattern that we will replace once we find the search pattern. So what the algorithm does, it takes a look at this whole grid. First, it generates randomly with a random seed all the elements in this grid, okay? And then it takes this, imagine this is lamps. This is called lamps. And the algorithm takes this lamps and it searches for the search pattern, which is 13, 0, 13, 13. 13, 0, 13, 13. Okay. Search lamps. And then the algorithm starts searching in the grid pattern for this sequence, element by element. Once it finds it, which is in this case here, then the replace algorithm, the replace function, replaces this pattern with the new pattern, with this. And this is how this random map generation mechanic works, okay? So the first step is randomly with a random seed generating all these elements. Probably there are also some rules when it comes to generating randomly these elements. And then it starts placing the mini structs randomly on the map, okay? And every time it finds the correct one, it places it and then goes to the next mini struct. Okay, this is just a rough idea on how this works. Can you do it in a different way? Definitely. You can separate the search and replace logic from the mini set struct. Then you can remove this size variable from the mini set. Then create all the level generation functions in a separate section with the goal to create a generic generate level function which will work for all levels. Okay? Reason is, when you find a bug in a generate room function, you can fix it at one place instead of having to do it on every single generate room function for every level. This is of course easier said than done, and without knowing the reasoning behind all these decisions, you should not jump to conclusions, especially in large code bases. Now, if we go through the other parts of the levels code, we will see a lot of code sections that look like this. Very long arrays that contain tiles. I mean, this enum defines tiles, so I guess all the values in here will represent a tile later on. And then also we will see a lot of code sections like this. And also, yeah, this, let's call it nested for hell. And as I said, if we go now through the other levels, we will see the same type of code repeating itself. And also in this file specifically, we have generate level function, which then starts placing these mini sets randomly somewhere on the map. Okay. And now if you go and take a look at these mini sets, I mean, you can open each of these and they're all defined in the same file. So for every mini set, you have to write the size, then the search pattern, and then the replace pattern. So anytime, I don't even know what this is, pancreas 2. So when the function finds a pancreas 2, it replaces it with this. What is a tree? Tree. Where are the tile definitions? I don't know. Oh god, what is this? Yeah, the code is full of sections like this. And again, I'm not criticizing this. This is a huge code base. This is a great project. The guys reverse engineered the Diablo 1 in C++ and it works. Now the question is it possible to rewrite this in something more readable? Maybe. Would I volunteer to do that? Hell no. Now, you can like it or not, but obviously this code works on a very large set of platforms, everything from PC to Nintendo Switch. And another thing I want to mention is code like this is more common in the industry than you would think. People who are just starting out have this misconception that code that ends up in production looks like something mythical. The reality is the end user will never see the code and they don't even care. The only thing they care about is it working properly and is it affordable? And to be honest, I have to admit, I really like this project. I had fun reading it, and if I had the time, I would definitely compile it and try to run it on a modern system. Like, I don't know, get a Nintendo Switch and try to play it on a Nintendo Switch, just for the purposes of nostalgia. I mean, if you think about it, how many projects or games are just unplayable today because nobody wanna take the time and port the game on a modern system. And in this case, it's not only a port, it's I mean, I'm not sure if Diablo was written in C++, Diablo 1 was written in C++, I would have to look into it, but this code base is definitely using some modern C++ features that were not available in the 90s. So big kudos. Really. Okay, so that's it for today. Let me know in the comment section if you have played Diablo, if you have any good memories about playing Diablo. If you like the content, hit like and subscribe, and see you in the next one. Tariq 10X.